Welcome to the second video for the Pure Mathematics course. Here we will continue Chapter 0 and Section 4, the operations of algebraic expressions. If simples are combined by any or all of the operations, the resulting expression is called algebraic expression. A polynomial is in X is an algebraic expression of the form like this, where x, n constant and n is a non-negative integers and cn is a constant. Let's take some example for algebraic expressions. Here the third root for this fraction is an algebraic expression with variable x. Another one here, this is an algebraic expression with variable y. See here this fraction which is added to 2 is an algebraic expression with variables x and y. Now let's take an example for subtracting algebraic expressions. Simplify this value. To simplify with this value, we will distribute the negative sign onto the second algebraic expression and getting it negative 4x to the power 2y minus 6x plus 3. Then we will add the similar terms to each others. So we will add here 3x squared y minus 4x squared y 2p minus x squared y, and we will add negative 2x negative 6x, and the value will equal to negative 8x. And finally add 1 plus 3 and the value is 4. Here you are the list of products may be obtained from the distributive property. Now this rule is not for saving it, it's for practice more and more on it. If you use these forms to solve the examples for in chapter 1 and in the incoming chapters, you will be you will solve with the examples and exercise very easily. Don't save it, just practice more and more on these rules. So we will take examples to practice more. For example, rule 2, which is if we have two brackets and x plus a, which is constant or number, and x then plus p, another constant, this will be x squared plus a plus b x plus ap. So we here have an example, x plus 2 times x minus 5. So the result will be x squared plus 2 minus 5x plus 2 times negative 5. And by simplifying the result, we got x squared minus 3x minus 10. Let's move to another one by using rule 3, which is 3z plus 5 times 7z plus 4. By multiplying the two brackets by each other, we get value 21z to the power 2 negative 47z plus 20. Another example, by using rule 5, that if we have x minus a all to the power 2, we can get three terms from this value, which is x squared minus 2ax plus a squared. Let's take a numerical example. X minus 4 all squared equal to x squared minus 2 times 4x plus 4 squared. So the final value will be x squared minus 8x plus 16. Finally, in the slide, we will use rule 6, which is if we have the same value multiplied by each other, but only the sign is different, the value will be like this. I mean, if we have x plus a times x minus a, the values for the result will be x squared minus a squared. Let's take an example including a radical sign. Here we have two brackets. The first term in this bracket is root y squared plus 1, and the second term is 3. And we have the same bracket but it differs in the sign. Root square y squared plus 1 minus 3. The value will be root y squared plus 1 all squared depending on this rule minus 3 squared. This means that root square by the values root square all square by the rules of the radicals in section 03. Here square y square and the value will be y square minus and plus 1 minus 9 equal to minus 8. So the result will be y squared minus 8. Example 20, dividing a multinomial by monomial. If we have in the numerator x to the power 3 plus 3x and here in the denominator x. So we can't eliminate only one x. We should repartient this onto two fractions like this. X to the power 3 over x plus 3x over x. To be the result, here x by minus 3 minus 1 equal to x squared and x with x to plus 3. This is for P. Let's move to, this is for A. Let's move to the another one, which is B. P, 4 is 4z to the power 3 minus 8z to the power 2 plus 3z minus 6 all over 2z. So we will eliminate each term in the numerator with the same in the denominator. Like this, 4z to the power 3 over 2z equal to 2z squared minus 8z squared over 2z equal to minus 4z plus 3z over 2z equal to 3 over 2 and finally 6 over 2z equal to 3 over z. Let's move to the other section of factoring polynomials. If two or more expressions are multiplied by each other, the expressions are called factors of the product. Okay? Once again, we don't save these rules as it, but we practice more and more to get it very easily when we solve the examples and exercise. Let's go to the numerical example, common factors. The requirement is to factor this expression completely. By factoring this expression, we take the smallest number, the smallest power in the simples. If we have here two terms, 3k squared x squared plus 9k to the power 3x. So if we look at the numbers, we have 3 and 9, we will take the least to be a common factor 3. And here k squared k to the power 3, we will take the least to be the common factor. So we will take k to the power 2. And if we look to x squared and x, we will take the least. So the common factor will be x. Here we already decided what is the common factor. Let's put the rest of our example, which is 3k squared x. Open the brackets for the first term, we get 3k squared x squared, so the rest will be x only. The second term is 9k to the power 3 and times x, and we have a common factor 3x squared x. So the rest will be 3k. Number B, factor this polynomial all algebraic expression completely. We have three terms and we want to take a factor. Again, we will take the smallest value of numbers and the smallest power. Here we have 8, 6, and 2. We will take the smallest value, which is 2. We have here a to the power 5, a to the power 2, a to the power 4, so the common is a to the power 2, which is the smallest power. We have here x, we don't have x here, so we can take this x as a common factor. We have y here, and y here, so we will take the smallest power for y to be the common factor to be y only. Now we can take p or z as a common factor because they don't exist in the first term. Now we will open the brackets and take the rest of the expression into the brackets for the three terms. 2p, 4a to the power 3x squared y squared. This is the rest of the first term after taking this common factor, and minus 3p to the power 3z. This is also the rest of the second term after taking this common factor. And finally, the third term will be a squared plus times p to the power 4xyz squared. This is for factoring this polynomial completely. Let's move to the number c. The requirement is to factor 3x times x minus 2 all squared minus x squared times x minus 2. The solution, we will have two terms, and we will take from each term the smallest number and the smallest power for the temple. Here, if we have the smallest number, we can't because it's 3 and 1. We can't take a number. So let's take, or maybe we can take 1. Okay, let's take now 3, the first term, x, 3x, and x squared. So we will take the smallest one, which is x. X minus 2 squared and x minus 2. So we will take x minus 2. So our common factor is x times x minus 2. And we will open a brackets for the rest of our expression, which is here x times x minus 2, and rest is equal to 3 times x minus 2. And negative sign for the requirement is here. Then, if we have a common factor x times x minus 2 from the second term, the rest is x. Let's continue. Here, we will simplifying by multiplying the x inside x with 2, x times 3. So the result will be x times x minus 2, which is our common factor, times 3 times 2 equals 6, and x times x plus x equal to x plus x. Here is positive, positive times positive equal negative times negative equal positive sign, so it will be positive 2x minus 6. And the final result will be 2x times x minus 2 times x minus 3. Let's move to another example for factoring completely. We have this expression. In this expression, we have two terms. The first term is 4 times x 2x plus 3 all to the power 2 times x minus 5 minus 12 2x plus 3 times x minus 5 all to the power 2. Now we have 4 and 12. We will take the least value to be a common factor. We will take 4. Then we have 2x plus 3 all to the power 2 and 2x plus 3 only. We will take the list, which is 2 to the power 2x plus 3. The third value, which is x minus 5, and x minus 5 all to the power 2, so we'll take the list which is x to the power x minus 5 only. Now, if we note that we have, this is for our common factor, and we will take the rest of values to be inside the brackets. Here, for the first term, If we take it from this a common factor this, the rest will be 2x plus 3 only. And if we take from the second term this a common factor this, with the rest will be 3 times x minus 5. Now it's easy to simplifying this result to be 4 times 2x plus 3 times x minus 5 times minus x plus 8. Let's move to the fraction part, or the sixth section in this chapter, which is simplifying fractions. How to simplifying fractions? We will simplify fraction to or by multiplying or dividing the numerator and denominator by the same non-zero quality. This how to simplify the fraction. The rule for multiplying and dividing is as follows. If we have multiplying two fractions, we will multiply the numerator by each other and denominator by each other also. The rule for dividing, here the first term will be the same, but the second term will be opposite the numerator and denominator and the multiplying. Let's move to examples to be more specified. Example 27, simplifying fractions. When we have this fraction and we want to simplify it, we should first make it two brackets to get it more simply. If we convert x squared minus x minus 6 into this form by using the rule in the previous section, we will get x squared minus x minus 6 equal to x minus 3 times x plus 2. And then the same for the denominator, which is x squared minus 7x plus 12 will equal to x minus 3 times x minus 4. We will eliminate x minus 3 by x minus 3, and the result will be x plus 2 over x minus 4. And we sure that x will never equal to 0, because if x equal to 0, so this value will be 0 and the solution will not be defined as the denominator will equal to 0. And we can divide by any value that contains the 0 in the denominator. Okay, let's move to another example for simplifying fractions, which is 2x squared plus 6x minus 8 over x8 minus 4x minus 4x squared. Let's take it in this form by taking first 2 as a common factor, because we have here 2, 6, and 8. So we can take 2 as a common factor. And the rest we can get it into by multiplying 2 brackets x minus brackets x minus 1 and x plus 8, 4. The same we will take in the denominator a common factor 4 and take the rest equal to 1 minus x times 2 plus x. We equal to x plus 4 over 2 minus 2 times x plus 2. And also be sure that x will never equal to 1, because if x equal to 1, this means that the denominator will equal to 0. Another dividing fractions examples. A, if you have the following value, x over x plus 2 divided by x plus 3 over x minus 5. First step, we will convert it onto a multiplying form. This will be the first term remain the same, and here we change the denominator to a numerator and the opposite. Here x over x plus 2 is the same, and here multiplied by x minus 5 over x plus 2. Then we will multiply numerator by each other and denominator by each other, so the result will be x times x minus 5 over x plus 2 times x plus 3. Number B, x minus 5 over x minus 3 all to over 2x. Now we will take the denominator here as this fraction, which is x minus 5 minus over x plus minus 3 here, and the denominator here will be 1 over 2x. Why? Because it's was divided by 2x over 1. And if we change the division sign to multiplication sign, we also change the denominator, and the opposite. So we will multiplying the denominator by each other to get x minus 5, x minus 3 multiplied by 2x to get 2x times x minus 3. Let's move to another one, which is we have here we have fraction in the denominator and we have fraction in the denominator. So we will take the first fraction as it, and the second fraction get the denominator, and the denominator for denominator here in the top and denominator in the bottom. So 2x squared plus 8x will be here in the bottom, and x minus 1 will be the top. And multiplying the two numerators by each other, so 4x times x minus 1, 2p, 2x, and x squared minus 1 times 2, x squared plus 8x equal to x plus 1 times x plus 4. This value or this result after simplifying the results until we reaches the example 25. We already finished this chapter. Be sure that the chapter 0 is very important for you because it have all the rules and the tools that we will use it later in the chapters for the equations, inequalities, differentiation, integration. We will have use we will take these tools, and very important. Practice more and more to get easily in the chapters below. Thank you for listening, and God